This is another GCE question under chemistry practical, titration to be precise. As I told you, you don't need to do anything in the laboratory. They will give you all the question and you have to solve it based on the knowledge. This is another question. Now, A is a solution of an acid HX containing 6.80 gram, okay, of the acid in 1.0 dm cube of solution. B contains 0.098 gram of sodium hydroxide, okay, 250 cm cube of solution, okay. So solution A was titrated against 25.0 cm cube portion of B. So equation of reaction is this. So this is the equation of reaction. Okay. So the results are presented in the table. So look at the table here. So they've given you the table. So it's from the table that they got the average theta value, which is 22.15 centimeter cube. Suggest with a reason an indicator for the reaction. Give the color change of the indicator. State why the titration was repeated 3 times. Calculate the, now they told us what to calculate. Mention 3 precautions to laboratory apparatus used, and that's all. So let's take them one after the other. With everything being said, A now, we are being told to suggest with a reason an indicator for the reaction. Give the color change of the indicator. We can all see that this is a strong base. It's a strong base. And this also, HX, for sure will be a strong acid. Now, when you have a strong base against a strong acid, or let me see, they say containing this of acid in this solution, but we are not sure. This can be a strong base and can be a weak base acid. This can be a strong acid or weak acid, pardon. So we have to play safe. Now, if it is a strong acid and strong base, an indicator can be used. But now we are sure it's a strong base, but if it's a weak acid, so it's very safe for us to mention that phenolphthalein is it. Okay? Phenolphthalein should be for A. Now, A suggests with a reason an indicator for the reaction. So the indicator for the reaction should be what? Phenolphthalein. Okay? The indicator, okay, should be phenolphthalein, because phenolphthalein, as I've said in the earlier video that I made, phenolphthalein is good for weak acid and strong base. And this acid now, we are not sure maybe it is strong or weak, but this one is a strong base. So even if this weak acid or strong acid, phenolphthalein still goes for it. That's it. So let's go to the next one. Wrong spelling of which one, please? Of the phenolphthalein. This is phenolphthalein. It's not a wrong spelling. Please, I don't know which one you are talking about wrong spelling. So let's go on, please. Now, this is the table. From the table, now suggest with a reason, an indicator. We have said that, and we have said the reason. Okay? State why the titration was repeated 3 times. I'm sorry. I will improve on my handwriting. Sorry, please. Sorry, please. State why the titration was repeated 3 times. Now, the titration was repeated 3 times because to ensure accuracy. So this one, state why the titration is repeated 3 times. So our B now. It was repeated. I think my handwriting is now good because some people are complaining about my handwriting, please. It was repeated 3 times. Okay? It was repeated 3 times to ensure accuracy and concordance and concordance of titer value. And concordant of titer value. Look at it now. First titer, second titer, third titer. When something is done repeatedly, it's going to confirm that you have the accuracy on ground for doing it 3 times. Concordant means they must not be different. The difference between the titer value must not be more than plus or minus 0.20 centimeter cube. It must not be more than this. So looking at the question properly now, you can see what we have here. There is an error here. Look at it, they are not concordant. This is rough titer. It will not be used in the titration or in the calculation. But this will be used. 25 is too much. 22.10, 20.90, they are just too much. Because their difference must not be more than plus or minus 0.20. But if you look at them properly, look at the first one from the candidate now, 25.20. Okay, 25.20, 22.10. And we have 20.9, 20.90. If we look at it very well, the difference is too much. Between this and this, there is a difference of 3.10. Between this and this is not concordant. It's not concordant. Between this and this, the difference of 2 is not concordant. It's too much. The gap is way too much. So there is an error in this titration which they want us to get. And that was why they gave us the original titer value. Okay. Now, calculate the concentration of B in moles per dm cube. This is our B. We have to calculate the concentration in moles per dm cube. There is a formula that we need to use. So concentration in moles per dm cube is equal to concentration in grams per dm cube. Okay, is equal to concentration in grams per dm cube divided by molar mass. And that will be in gram per mole. This formula is taken from the formula of mole. You know, amount in mole. Amount in mole is equal to mass over molar mass. Mass over molar mass. Now, our mass is in gram. Molar mass is in gram per mole. And our mole is also in mole. Okay? Now, the difference between here and here is that dm cube is added. And dm cube is added over here also. So what we have here is what? Per dm cube. Also per dm cube. And that's from this formula. So we are told to find the concentration of B in moles per dm cube. So all we needed from B, which is sodium hydroxide, all we needed is the concentration in grams per dm cube, and we need the molar mass, and we can get that from the question. What did they give to us? For B, we have been told that B contains, you can see, B contains 0.98 gram of sodium hydroxide in 250 cm cube. Wow. What are we going to do? We have to say this. We have to say 250 cm cube, 250 cm cube of B. You see now, requires 250 cm cube of B. 250 cm cube of B, as you have it here, 250 cm cube of B requires 0.98 gram of sodium hydroxide. 0.98 gram. So we have to say 250 cm cube of B requires 0.98 grams of B. So to calculate the gram per dm cube means gram in 1 dm cube. And what is 1 dm cube? 1 dm cube is also 1000 cm cube. So 1000 cm cube of B requires, so we have to cross multiply. So this multiplies this. This multiplies this. So you have 1000 times 2 times this 0.98 divided by 250. Somebody is asking about the color. Oh, yeah. I'm sorry, please, let's go back there. Suggest with a reason an indicator for the reaction. We have said that. And so give the color change of the indicator. Okay, wow. Now, I have to say that now, before I go on. The indicator, let's take for example, methyl orange. Methyl orange changes color. If you look at it very well, methyl orange changes color from red. Let's go there. So phenolphthalein now. Phenolphthalein will change color in base, under bases. The color of phenolphthalein is always pink. It's pink in base. Okay? So when it gets to acid, because after the reaction, it goes to acid, so it turns colorless. So the indicator will turn from pink to colorless. So that's that. So let's go on, please. So this, we have 1000 times 0.98 divided by 250. So let's do the calculation and let's see what we get over there. So 1000 times 0.98 divided by 250. 3.92. It gives us 3.92. Now, it's in 3 significant figure, 1, 2, 3, which is correct. Gram per dm cube. So we have gotten that from this formula. We have gotten this. We have to get this also, the molar mass of your B. And your B is sodium hydroxide. Your B is sodium hydroxide. So the molar mass now, that's the next thing. The molar mass. So molar mass, let's go to molar mass. Molar mass of B. Molar mass of B, what will it give to us? Molar mass of B, and our B is what? NaOH. Now, sodium is 23 mass, plus oxygen is 16, hydrogen is 1. So if you have to add this together, this will give us 40. So we have 40 gram per mole. So to go to the question now, for us to calculate the molar mass, concentration of B in moles per dm cube. Using this formula, concentration in moles per dm cube is equal to concentration in gram per dm cube over molar mass. We have gotten gram per dm cube, which is this, and we have gotten our molar mass. So the next thing is for us to slot it into the formula. So it means concentration in moles per dm cube of B will be equal to, now, gram per dm cube 3.92 divided by 40. So 3.92 divided by 40. So that gave us 0.098. So it will be 0.098. It should be in 3 significant figures. So 1, 2, we have to add 0. Moles per dm cube. That's moles per dm cube. Okay. So that's the concentration of B. So we are asked to calculate the concentration of A in moles per dm cube also. To do this, we have to use our CAVA is equal to CBVB. Looking at this, the number of mole of A acid is 1. Number of mole of base is also 1. So it will be 1:1. So we have to use CAVA. CAVA over CBVB is equal to NA over NB. Let's go for the value one after the other. Our CA is what we are told to calculate. Okay, our VA, that is volume of acid, is given. Volume of acid is 22.15. So volume of acid will be 22.15. Now, the next thing is the concentration of base. Concentration of base, what will it give to us? Now, concentration of base, I think is given. Oh, that's what we got here. Concentration of base is this. So we have to state it there as 0.0980. The next thing, volume of base. The volume of base is used in the titration and is given from the question. That is, solution, they said solution A was titrated against 25.0 centimeter portion of B. So that's our volume of B. That will be 25.0 centimeter cube. That's the volume of B. Now, to calculate now, let's slot every value in. Don't forget our NA is 1, NB is also 1 from the equation. NA is NA here. Where is it? NA is 1 and our NB is also what? 1. So it means let's go on. So CA now, we don't know that. VA is this times 22.15 divided by CB, which is this, times, we have our VB, which is 25.0, is equal to NA is 1, NB is 1. So we have 1 over 1. So we do our cross multiplication. This goes here. So we have our CA times 22.15 times 1 is equal to, this goes here, 0.0980 times 25.0. Multiplying this is not going to change. So we have our CA is equal to 0.0980 times 25.0 divided by this. So divided by 22.15. Okay. Now, this question, somebody asked that what grade is this? This question is for grade 12. It's for grade 12, for class 12. And it's also for university students at the part 1. It's an alternative to practical. It's a GCE question. It's an entrance question that makes students to pass and go to the university. So it's an entrance question. So when we do this calculation, so this calculation gives us 0.098 times 25 divided by 22.15. So our answer here is 0.1106. So that should be 0.1106. So to take it to 3 significant figure, it will be equal to 0.111 mole per dm cube. So that's the answer for that. So let's go to the next one. The molar mass of A. How do we get molar mass? Now, we can use the same formula that we have used before. Okay, where we say the concentration, please permit me to shorten it. Concentration, okay, in moles per dm cube, okay, it will be equal to conc in gram per dm cube over molar mass. Now, we have to calculate the molar mass. So it means we needed this, and we know that already. And that has been calculated, which is this. that we just got now. Okay, so we have to put that there, and the concentration in gram per dm cube is what we put there also. So this we have to put 0.111, okay, moles per dm cube is equal to, now, concentration in gram per dm cube. It is given from the question. Let's look at it. A is a solution of an acid, HX, containing 6.80 gram of the acid in 1 dm cube. That means that's 6.80 gram per dm cube. That's the meaning. So anywhere you have gram per dm cube, you can slot it in 6.80. So here we slot 6.80. We call it gram per dm cube. Okay, divided by molar mass. So we have to make molar mass the subject of the formula. We cross multiply. This goes up and this comes down. So we have molar mass is equal to, so this goes up and this comes down now, is equal to 6.80, okay, divided by, so we have this. So divided by 0.111. So what do we get there? So it means 6.80 divided by that. So this will give us 61.48 gram. So that's the molar mass. So we have gram per mole. So that's the molar mass. So we have to get there. Yeah. So they ask us what's the relative atomic mass of X. Relative atomic mass of S. How do we get that? It's not hard at all. Now, they gave us HX. So we know now that our HX will be equal to this that we got. Will be equal to 61.48, which is the mass. This is the molar mass of this compound. So they want us to get the atomic mass. And atomic mass will be the addition of this mass and this mass. And this hydrogen is 1. So 1 times X is equal to 61.48. So it means that we divide both sides by 1, which will not change anything. So our S also, which is the relative atomic mass, will be 61.48. That's the relative atomic mass over there. Okay, that will also be gram per mole. That's relative atomic mass. It's still the same. So that's the answer for this. Relative atomic mass. Now, there's another thing. D. Mention 1. 3 precautions taken during the titration. There should be 3 precautions to be taken during the titration. What are the 3 precautions? Number 1. Rinse the burette with the acid to be used. We have to rinse the burette with the acid to be used. That's the first thing. Second thing, rinse the funnel from the burette before titration. So before you titrate, you have to remove the funnel. You don't leave the funnel on it because it will add to the drop of the titration. So do not blow the last drop of alkaline at the tip of the pipette into the conical flask. So you don't blow. You must not blow. So that's another thing over there. So this now. Mention 2 laboratory apparatus used in the titration. Very simple. The major one is the pipette and the burette. Thank you for watching. If you did not understand any aspect, you can rewind or you pause it as the case may be. See you next time. Thanks and God bless you.